The question says that verification of Green's theorem, right? Earlier I said that given any type of problem under Green's theorem, we have different types of problems under Green's theorem. The first one is what? Verification of Green's theorem, right? What's the first one? The first one is verification of Green's theorem. The number 2 is what? Calculating the flux or circulation. Then number 3 is what? Simplifying complex integral. Now, out of these 3 types of problems, number 1, verification of Green's theorem. Now, the whole idea is that what we've done before, that's what we are implementing. Now, before your Green's theorem can be verified, given a question, before your question is being verified by Green's theorem, what it means is that the line integral must be equal to the what? Double integral. The line integral must be equal to the double integral. Meaning that it's just like we saying doing algebra. From algebra, let's say you have x plus y is equals to 2x plus 4. God is the left hand side and God is the what? Right hand side. This equation, okay, let's say the value of x is equals to 2 and the value of y is equals to 4. This equation can be true after substituting both value of x and y to the left hand side and to the right hand side, and they are equal, meaning these two values, they are correct. I get what I'm saying. Let's say you substituted the value of 2 and y into the left hand side and you got 8. You've also substituted the value of 2 and 4 into the right hand side and you also got 8, meaning that this value is correct for this given equation. Are you getting it? So that's what we are doing. We are also doing a similar thing here, meaning before you're given a question, before that question can be verified under Green's theorem, it means that the line integral must be equal to the what? Double integral. Now, mathematically, this is what we are saying. When we say line integral, meaning integral c all into bracket Pdx plus Q dy equals to double integral r all into bracket the partial derivative of q with respect to x minus the partial derivative of p with respect to y multiplied by the a. Now, earlier I said to verify Green's theorem, meaning the left hand side must be what? Equals to the what? Right hand side. Now, this left hand side is what we call line integral. This is the line integral. This is the line integral. Why this is the double integral. So now, the overall idea is that you are going to solve this question using line integral. This given question, you are going to solve this question using line integral. And you are going to solve this question using what? Double integral. Solving this question using line integral and solving this question using double integral, your answers must be the same. If they are the same, hence Green's theorem is what? Verified for this particular question. If otherwise, meaning Green's theorem is not what? Verified. So what we just need to know is the step how to solve it. How do we solve this question? What we just need to know basically is the steps to implement when solving line integral for a particular question and when solving double integral for a particular question. Alright, now from here, let's solve this first one using double integral. Now, from this general formula of Green's theorem, identify what's the formula for double integral? Double integral r, right? Double integral r all into bracket the partial derivative of q with respect to x minus the partial derivative of what? P with respect to y multiplied by the a. Now, from this given question, this is the given question, right? From this given question, we have that integral c all into bracket y square dx plus x square dy, right? Now, from here, identify to get the partial derivative of q with respect to x. What it means is that we differentiated q function with respect to x, right? We did our partial derivative. So let's say this is question mark. Similarly, to get this guy, meaning partial derivative of p with respect to y, another partial derivative. Now identify what's the function of p here. What's the function of p? What's the function of p? And what's the function of q? Relate this given, this is the given question. Relate this given question to your line integral. Relate this given question to your line integral. Now identify what's the function of p. P is what? Y squared. Let's do comparison to see how it works. From your line integral, this is what you have, right? Integral c all into bracket p dx plus what? Q dy. This is the line integral. Relate it to your given question, meaning integral c all into bracket y squared dx plus x squared dy. Doing comparison, what's p, what's q? Call this one, call this 2. Compare 1 and 2. What's the value of p? What's the function of p and what's the function of q? P is equals to y squared, p is equals to y squared, and q is equals to what? S squared. Meaning that p is equals to y squared and q is equals to what? S squared. Now come back to this double integral. What do you need? What are the unknowns? The partial derivative of q with respect to x, the partial derivative of what? P with respect to y. Now let's solve. From this place, let's solve. What will be the partial derivative of p with respect to y? This is what? 2y. What is the partial derivative of q with respect to x? 2x. 2x. Now substitute. Substitute. Meaning that integral r all into bracket. What? This one will be substituted with what? The partial derivative of p with respect to x will be substituted with what? Check what you have here. 2x minus 2y all into bracket. What the a means is your area, meaning that the a, take note, the a is equals to the x multiplied by dy. So substitute that also, meaning the x multiplied by dy. Up to this level, we want to integrate. We said double integral, double integral. Then observe, we have the integral with respect to x and the integral with respect to what? Y. Meaning, I have two integral sign here. Meaning the first integral, I'm going to integrate with respect to what? X, and I'm going to integrate with respect to what? Y. Now, in this case, the type of integral we are doing is called definite integral. By definite integral, you have your lower limit and your what? Upper limit. You have your what? Lower limit and you have your what? Upper limit. Now, what you are going to substitute from the question, let's read the question. Let's read the question. The question says that evaluate integral y squared dx plus x squared dy for c, comma, the square bounded. What this means is that different type of, from Green's theorem, we said we have a what? Simple closed curve. Let's say this is, let's go back to what Green's theorem states. Let's say this is your simple closed curve. This is C, right? This is C. This is also C. Now, this single closed curve might be of different shape. You might have a square. Are you getting me? You might have a square. You might have a triangle. It might be of different what? Shape. It might be of different shape. Now, back to the question. What type of shape do we have here? Square. Meaning that the single closed curve, in this case, is what? Square. Now, relating this question to line integral, it becomes what? You have your y-axis, then you have your square, right? You have your square, and this is your C. This is C. Then, if this is your C, then the enclosed area is what? R. It is R from what we explained earlier. But you see how it works. That's when you are solving using line integral. You see how it works. But from here, what I'm just trying to say is that this C in this case is what? Is in form of square. The shape is what? Square. Do you understand what I'm saying? Now, from here, when substituting your boundary, when substituting your upper and lower limit, it was given from the question that x is equal to what? 0, meaning x ranges from 0 to what? 0 to 1. Then y ranges from 0 to 1. Now, for this first integral, let's say this is x. Let's say this is x, and let's say this is y. From here, let's recall from definite integral. Say you have integral of a to b, call this f of x. By that you integrate, meaning f prime of x. Introduce your limit, right? Meaning that the upper limit and the what? Lower limit. I get what I'm saying? From definite integral, say you are given this function of integration. When you integrate, you have f prime of x. Having done your integral, meaning you've integrated, you got f prime of x. Let's say you've integrated, meaning fx plus c, right? By the time you integrate, introduce your limit, meaning the upper limit and what? Lower limit. That's what we are doing here. Now, for this x limit, the lower limit, check this value of x. What will be the lower limit? 0. The smaller number is the first one, the lower limit. So for x, for the integral of x, the lower limit is what? 0 up to what? 1. Similarly, for y, what do we have? 0 up to what? 1. Any question? No question. Now let's integrate. We are integrating this function, meaning 2x minus 2y. We are integrating it twice. The first one is with respect to x, and the second one is what? With respect to y. We are integrating 2x minus 2y with respect to what? X, and we are also integrating with respect to what? Y. Now let's integrate with respect to x. What's our answer? Integrate 2x minus 2y with respect to x. That becomes what? Let's integrate. What do you have? Implement the idea of integration. What do you have? This becomes what? Integrate with respect to x. You have 2x always power of 1 plus 1, right? Divided by 1 plus 1 minus 2yx. Is that correct? Meaning, let's go back to integration class. Let's say you have integral 8 dx. Then your integral becomes what? 8x plus c. Similarly, when we have integral 2y, you can relate this as what? Constant. Meaning, your new integral, that's 2yx. 2yx, and that's what we did here. Now, from here, meaning you have 2x squared all over 2 minus 2yx, right? Then 2 cancel out. You are left with what? X squared minus 2yx. X squared minus 2yx. Meaning that from this question, from this form, you integrated with respect to x. This is what you got, right? And we said after integrating, you are integrating with a particular function. Say x, introduce the limit. Introduce the what? The limit. Say you are integrating with respect to y, introduce the what? Limit. Now, what is the limit here? What will be the limit that I'm introducing here? 0 and 1. From what we have here, we have what? 0 and 1. Meaning, this is 0 and this is 1. Now, let's substitute. Anywhere I see x, I have what? 1. Minus 0. Meaning, 1 square minus 2y, all into bracket 1, right? Minus what? 0 square minus 2y, 0. Then this becomes what? 1 minus 2y minus 0, which is still the same thing as what? 1 minus 2y. Meaning that from here, I integrated with respect to x. Then I introduced my limit. I got this, right? That's my first integral. Then your second integral says that when you've integrated, integrate it with respect to x, with respect to y. The first one is integrate with respect to x. The second one is now what? Integrate with respect to y. Now, what we've got here, let's integrate it with respect to y. Meaning, I have integral 1, 0, all into bracket 1 minus 2y dy. Now, let's integrate with respect to y. What do you have? When you are integrating integral 1 with respect to y, dy, what will be the answer? Y. The answer is y. Are you getting me? Now, from here, it becomes what? Y minus 2y squared all over 2, right? 2 cancel out. What do you have? Y minus y squared. Introduce your limit. 1 and 0. Meaning that 1 minus 1 squared minus what? 0 minus 0 squared. By the time you evaluate this, what's the answer? This is what? 1 minus 1 minus 0 minus 0, right? Meaning I have 0 minus 0, which is equals to what? 0. Which is equals to 0. Meaning that, given this question, I solved this question using double integral. I got what? 0, 0. Meaning that solving this same question using line integral, I must get what? 0. Me getting 0, what does it mean? It means Green's theorem has been verified for this question. If I'm not getting 0, it means Green's theorem is not verified. So that's the whole idea. Meaning that you are going to solve your question using line integral. By the time you solve your question using line integral, that same question, solve that same question using double integral. Using double integral, you must get the same answer. If you are getting the same answer, it means Green's theorem is verified. If otherwise, Green's theorem is not verified. Alright, now let's solve this same question using line integral. Let's solve this same question using line integral to see how it works.